Hey, this is Mr. Beckstrom, and I just wanted to go over the last two problems from the review that we didn't get a chance to do in the review session. So here's number 11. I've actually already worked this all out and recorded it, but my recording software crashed, so I already have it worked out, so I'll go through what I did on this. The answer for this was two solutions that made this equation true. It was 7 minus 2i and 7 plus 2i. And remember, I is equal to the square root of -1. So let me just go show you how I found that. So I have this equation right here. If I tried to factor it, I would find out pretty quickly that there's no easy way to factor it. 53 is a prime number, so the only multiples of that, or the factors of that, are 1 and 53, so there's no way to get a -14. So here is the quadratic formula: negative b plus or minus the square root of b squared minus 4ac over 2a. The radical part here is called the discriminant, and I checked the discriminant here first. So a is 1, b is -14, and c is 53. They're just the coefficients in front of the descending variables. All right, so I just plugged it in to that radical there, and I get -16, the square root of -16, which I can pull out a square root of -1 and turn that into an I. So that's I times root 16, and square root of 16 is 4. And multiply that by I, we have 4i. So that's just the discriminant part, and I just figured that part out first in order to see if this was if we had real solutions or if they were imaginary solutions. And because we got a negative value under our radical, that tells us that we have imaginary solutions. So finally, I just went back to the quadratic formula equation, plugged everything in. The discriminant here, I already figured that out, so I didn't have to write the whole thing again. Simplified it. Then I broke it up into two fractions here: 14 over 2 plus or minus 4i over 2, and that becomes 7 plus or minus 2i. So that's two solutions: 7 plus 2i and 7 minus 2i. So I went ahead and put those in, got a little correct symbol, and lets me know I'm right. So that means if I put either of these solutions in here for x and multiply this all out, we get 0. All right, for the next problem, I did that one as well. So let me just kind of describe what I did here. They gave me a piecewise function. So it's one function if x is less than 0. It's another function if x is equal to 0. And it's a third function if x is greater than 0. So whenever we evaluate it, first we have to figure out which of the three situations we have. And none of these should ever overlap. If they do overlap, then we don't have a valid piecewise function. So knowing that, the first thing says evaluate the function at -2. Well, because -2 is less than 0, I'm going to use this top equation, which is basically y is equal to x squared. Put a -2 in there for x. -2 times -2 is 4. The second one, f of 0, I go down here, and it's this middle one here because x is equal to 0 in that case. And the equation for that is basically just y is equal to 3. So we just put a 3 in there. If there's no variable, then there's nothing we have to compute. We just put whatever values in. And then the last one, f of 1, going down here, 1 is greater than 0, so we use this equation, which is basically going to be y is equal to 3x plus 3. We plug the 1 in. 3 times 1 is 3, plus 3 is 6. And that's how I got my 6. And that's it. If you have any questions, let me know. The test will be available Monday. Good luck, and have a great weekend.